check, mic check, mic check. Hello, check, mic check, mic check. Hmm? Check, mic check, mic check. Hello, check, mic check, mic check. Hello, check, mic check. Hello, check. Hello, 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 hello. ಕೇಳಿಸ್ತಿದೆ. Hello, check. Mic ಇದರಲ್ಲಿ. Hello, check, mic check. Hello, check, hello, check. ಕೇಳಿಸ್ತಿದೆ. Check, mic check, mic check.
Good evening, one and all present here. Welcome to this lecture series, Benefits from Space. And today it is about the exploration of the mysterious planet Mercury. And this talk will be given by Dr. Guruprasad, Director of JNP. A brief introduction about the speaker. Dr. B.R. Guruprasad is the Director of this Planetarium, Bangalore. Before this, he has served as a satellite scientist in satellite mission planning and later heading the media and public relations wing of ISRO. Apart from all this, for more than 2 decades, he has been very active in science communication, which is his passion. He has authored 13 books, among which some have been translated to various Indian languages, and he has contributed to various science articles published in reputed newspapers and magazines in both English and Kannada. He has been involved in teacher training programs, science quizzes, and conducting workshops for students from various parts of the country. I heartily welcome him and request him to start this lecture. Thanks.
Hopefully, am I audible? Yeah, thank you. Uh, Good afternoon to you, and I welcome you all on behalf of JNP for this lecture series, Benefits from Space. Contributed a lot to this, especially I want to thank all people, engineering and science staff, and for pertaining to visuals and such things, I want to especially thank our Deepak. Okay, so uh, you know, this series, when I say benefits from space, many people think that it is something to do with communication satellites or how we have all the facilities like, for example, anywhere in the world, thanks to Starlink kind of satellites or even Iridium kind of satellites, we can converse with anybody else. Or we have weather pictures of the earth, okay? And we can survey and through that manage our natural resources. And of course, everybody knows GPS, okay? Especially we have been hearing a lot about the GPS enabled bombs and missiles in the Iran-Israel conflict. I'm not talking about those things. You see, at the same time, human activity in the domain of space has enabled humans to learn a lot about the solar system as such. In the past 60 years or so, 60 to 65 years, there has been a revolutionary growth in our understanding of the solar system, especially some of the planets. But one planet, Mercury, is still mysterious in many respects. And though it is relatively near to us, near the Earth, it has not been the target of many spacecraft. In fact, to the distant body Pluto, I don't call it as planet, a dwarf planet now. Humans have sent enthusiastically, but it is not so easy to send something to Mercury. But anyway, it is very, very difficult to observe Mercury from the surface of the Earth due to various reasons. I will come to that. But thanks to space flight, thanks to robotic spacecraft, we have learnt a lot about planet Mercury, which we would not have been able to had it not been for robotic spacecraft like many of them, like say Mariner 10 or Messenger or now Bepi Colombo. Now, without wasting much time, let me go to the subject directly. Exploration of the mysterious planet Mercury. If I were to observe the planet Mercury from the surface of the Earth, or even from space in Earth orbiting through Earth orbiting telescopes, I would have said observation. When I am putting exploration, it says something is going near that or traveling towards the target planet, and that is how making us aware of what is special about planet Mercury. Now, very fundas, you may laugh at it. All of us know that solar system consists of the sun, which is a star, and 8 large bodies revolving around the sun, which we call as planets. And there are other class of bodies like comets, asteroids, okay, between Mars and Jupiter, largely, not always, okay. Then you have got dwarf planets even, okay, comets, dwarf planets, and asteroids, meteorites, small pieces of comets and asteroids, as well as planets. And of course, I'm sorry, I forgot, planets and their satellites even. So they're all wonderful worlds. Now, we have different planets of the solar system, but this slide was made long back. That's why even Pluto is there in that. But suffice it to say, we have the first planet from the sun, Mercury, then Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Pluto is there anyway, nothing has happened to it. Our perspective has changed, that's all. So there are different distances from the sun. I'm giving you the details of this just to tell you what is so special about Mercury. Mercury on the average is at a distance of 6 crore kilometers from the sun. On the average, I'll put in lakhs and crores only, not millions and billions, with which we are not that familiar in India. 6 crore kilometers on the average, 6 crore kilometers Mercury, 11 crore kilometers Venus, roughly. Earth, 15 crore kilometers, Mars, nearly 22.5 crore kilometers, Jupiter, 78 crore kilometers, Saturn, 145 crore kilometers, Uranus, 285 crore kilometers, Neptune, 485 crore kilometers. Just for the sake of contextually, I can say Pluto, which is called as a dwarf planet, is on the average at a distance of 600 crore kilometers. 600 crore kilometers from the sun. Now, from time immemorial, humans have observed the night sky first with the naked eye, then with telescopes, in fact. Okay, if you observe the night sky either through the naked eye, okay, or unaided eye, or through the telescope, okay, let us not go to telescope immediately. Now, if you look at the night sky, you know, there was a lot of reports and a lot of hype was there about 5 months back, so-called planetary parade, and it was popularized in media as though all the planets are side by side. They appear to us, all 7 of them, okay. It was not the case. We could able to observe only 4 properly, okay. But anyway, in this picture, you will see Mars clearly visible, Jupiter, Saturn, and Venus. Of course, all of them are visible to the naked eye, no doubt about it. But, you know, Mars is the next planet from the Earth, Jupiter is next to it, Saturn is next to it, and Venus on the other side. This is the nearest planet to us, visible, no doubt about it. Now, let us come to the telescopes, okay. This is European Southern Observatory Telescope in Chile, in the midst of Atacama Desert, okay. Very dry air will be there. That's why they at a high altitude they have constructed this, okay, Atacama Telescope. And if you look through a telescope, this is the way Venus looks. See, Venus also presents phases. In fact, this is the phase we saw very clearly 5 months back. So Venus, it is like crescent Venus, like crescent moon. Then Mars, okay, it's quite visible. In fact, you can see the surface of Mars from the Earth using a telescope, powerful telescope. You can see, okay, you can see the polar ice caps also there, and the planet per se. What you are looking at is not the atmosphere. Here, you are looking at the atmosphere of Venus, not the surface. Here, you are looking at the surface itself. Then, what you see in the case of Jupiter is atmosphere only. Atmosphere itself is very thick. Okay, you can kindly remember that Jupiter is quite far away. Okay, it is 78 crore kilometers from the sun, means roughly 55 crore kilometers is the average distance between Jupiter and Earth when they are very far away. Even when they are very near. Then Saturn also can be seen like this. Quite okay. Uranus, of course, using a telescope you can see. Big telescope, you can see Uranus has got 5 large satellites. 2 of them are visible, Titania, Oberon. So similarly, Ariel, Umbriel, and Miranda are the other 3 satellites which are not visible in that. This is Neptune, okay, the 8th planet or the last planet from the sun as we know it today. You can see, and one of the satellites of probably, I'm not sure whether it is Triton or it is some star. Suffice it to say, why I have shown all these things, all these planets are visible relatively easily. They are high in the horizon, quite a bit, okay? You can observe them without difficulty if you have a good telescope or through the naked eye, but not many details are visible through the naked eye. But look at this planet, which is not so. This is planet Mercury, the first planet from the sun. Nobody knew how it looked till 1974, okay? Till 1974. This is actually how the surface of the Mercury looks. This is a mosaic and the animation done by NASA. Look at it. So how different features, surface features are there on surface of Mercury. Okay. Next, let us go to Hubble Space Telescope. Okay, you are not able to see Mercury from the surface of the Earth for a reason which I'll come to it a little later. We have Hubble Space Telescope, one of the finest telescopes in orbit, circling the Earth at a height of 600 kilometers. Okay, but why it's not able to observe Mercury? It has no limitations which are normally there for a terrestrial telescope. But why not? And look at that. It has even taken Hubble Deep Field, whatever it is. You know, that is what astronomers call. That is 14 billion light years away. It has taken picture of galaxies. Why can't it see Mercury, which is very near? Mercury, again I repeat, 6 crore kilometers from the sun on the average. We are at 15 crore kilometers. That's all. Why? Why can't it? So look at that. How nicely it has taken the picture of Saturn, Hubble Space Telescope. Look at the way in which so nice it is. You can see the different hues, okay, and the polar ice caps of Mars. So nice. But why not Mercury? What about James Webb Space Telescope? Much more recent one. Oh, so capable. It is not circling the Earth, okay, let us say circling the sun. And it is at a distance of, let us say, 1.5 million kilometers from the Earth in the opposite side to the sun. And it has turned away from the Earth and the sun always, okay? Look at that. When we think of James Webb Space Telescope, we think that, you know, it can see the first light when the stars came into existence. It can take pictures of that. That was the kind of PR, public relations thing people were telling. But James Webb Space Telescope can look at our own solar system also. No problem. Look at that. This is the picture of Neptune, okay? Look at that. This is the largest satellite of Neptune, Triton, and Nereid, there is the other one, and many other satellites of Neptune are visible in this. If James Webb Space Telescope can see Neptune, while at a distance of hardly about 1.5 million kilometers from the Earth, Neptune, I told you, on the average, Neptune is at a distance of 485 crore kilometers. We are only at 15 crore kilometers. Okay, at least more than 450 kilometers, 450 crore kilometers away. How? But if these things are possible, why not Mercury? Okay, look at that. The reason is this: Mercury is the first planet from the sun. And you know, Earth goes around the sun once in 365 days. Am I correct? Okay. But Mercury goes around the sun once in 88 Earth days. 1 year on Mercury is 88 Earth days. For us, it is 365. Because of that, Mercury is traveling so fast. And see, Earth takes 365 days, means 88 days, means Mercury would have circled the sun 4 times when we take only one, when we go around the sun once, we orbit the sun once. So nearness of Mercury to the sun is one important factor why it is not visible. Okay, when we say, you know, from the perspective of the Earth, the angular separation between Mercury and the sun, it is called as elongation. Angular separation cannot be more than 29 degrees, 28 degrees, 28, 29 degrees in fact. That means whenever sun is there in the sky, Mercury stays very near to the sun. Okay, so the implication is that Mercury is visible during twilight hours, or it is visible during early morning hours. That's all. 2 hours before sunrise or 2 hours after sunset at the most. But so what? We would have observed Earth's atmosphere is very turbulent. Okay, even when our atmosphere is quiet also, turbulence is associated with it. So when Mercury is very near to those, when sun is setting, then only Mercury also comes into the view because of its nearness to the sun. So, but turbulent atmosphere will not allow you to look at Mercury in a focused way. Second thing is, Earth is having an atmosphere, and that is why we have twilight first of all. Even when sun is below the horizon, we have twilight. Sky is not dark. Dark sky comes only after, let us say, when there is night, and Jupiter, Venus, Mars, Uranus, Saturn, all these things are visible high in the sky, but this is not the case. So this is the reason why. 2 things. One is nearness to the sun, and when it is visible, it will be twilight or early morning light will be there. So that is the reason why Mercury is not visible. See, Mercury, as I was telling, goes round the sun once in 88 Earth days. Once in 88 Earth days, it revolves around the sun, but it spins around its own axis once in 59 Earth days. So they call it as 3:2 resonance. Let's not go to very high sounding terms. But anyway, let us say Mercury goes around the sun twice. By that time, it would have rotated, it would have spun around its own axis 3 times. You can see that red colored mark, how it is moving. Okay? So this is a stable system, in fact. What about the size of the Mercury? Look at the sizes of the solar system, inner solar system objects. Sorry, Earth. Earth is having a diameter of nearly 13,000 kilometers, 12,756. Then Venus has a diameter of 12,100 kilometers. Then Mars has a diameter of 6,800 kilometers to 6,900 kilometers. Moon has a diameter of, let us say, 3,476 kilometers. And what about Mercury? Mercury is 4,900 kilometers. That's all. It is a little bigger than the moon. Amongst the inner solar system objects, Mercury is the smallest planet. Not only that, today Mercury is the smallest planet of the solar system. Anyway, Pluto has gone now from the planetary status. So that is the reason. So it's a very small world. At the same time, two associated things are there. Okay, that is very near to the sun and twilight. So these are the things. So look at the Earth. As I told you, Mercury's diameter is 4,900 kilometers. Earth's diameter is 12,756. 13,000, you can take it roughly. So that is it's a very small planet. So actually, no, you think that this is the picture of a planet? No. This is the picture of the largest satellite of Jupiter, as well as this is the largest satellite in the solar system called Ganymede. Okay? In 1609 AD, Galileo Galilei, actually, 1609-10 AD, he turned his telescope, the so-called spyglass, towards the heavens, and he looked for dots of light. Okay? Even today, those large satellites of Jupiter, they are known as Galilean satellites. In fact, we had a fantastic view. We showed it to almost 5,000 people, Anand may remember, in fact. So 5,000 people. So Ganymede, which is the largest satellite of Jupiter as well as the largest satellite of the solar system, is larger than Mercury. Look at the smallness of Mercury. Titan, okay? Titan is the second largest satellite of, second largest satellite of the solar system and the largest satellite of Saturn. Humans have landed on Titan. Yes. Okay, there was a probe called Huygens, after Christian Huygens, who put forth wave theory of light, you remember, in fact. Everything has got a basis in science. Okay, wonderfully, if you look at the astronomical concepts, everything is based on physics, laws of chemistry, and the way in which nature works, mathematics. That is the way. Okay, so Titan as well as Ganymede, both of them are larger than Mercury. Okay. So Mercury has been known to humans for the past 5,000 years. For 5,000 years, especially I'm showing this a picture of the civilization of Sumerians. Where were they? Sumerians were between Euphrates and Tigris, what is today's Iraq. Okay, that is where later Babylonians came, etc., etc., in the same area. But anyway, 5,000 years back, since 5,000 years, Mercury is known to humans. But not much was known about it. Okay? Mercury was known in ancient Greece first by two names. When early morning sky it was visible, it was known as Apollo. When it was visible in the evening sky as an evening star, it was known as Hermes. Okay? Then later they found that both of them were actually the same heavenly body. Later the Romans, who succeeded Greeks, okay, they gave the name Mercurius, okay, their messenger god's name, to this planet Mercury. It is Mercurius, not Mercury. Okay, now only part of it we have taken in English, Mercury. So why messenger god's name? It is because, relatively speaking, Mercury moves very fast in the sky. Compared to Venus, compared to Mars, Jupiter and Saturn. Only the ancients knew only these 5 dots of light in the night sky. Okay, that's the thing. Then, okay, for a long time humans were thinking that everything in this universe, whatever they thought, what was universe, actually it revolves around the earth. Earth is at the center of the universe. Why? Because God has created us with a special purpose. Where we are, that should be the center of the universe. There was nothing wrong in it, because wrong in it means that perspective, because it looks like that. It is apparent to us. But whether it is true or not, that is different. Okay. Copernicus, for a long time people were thinking, and it was codified very well by an ancient astronomer called Claudius Ptolemaeus, whom we know as Ptolemy, okay, Ptolemaic system. But anyway, in the 15th century, a Polish monk come astronomer called Nicholas Copernicus, okay, we know only his Latinized name. His name was not Nicholas Copernicus. His name was Nikola Kopernik. He is a Polish fellow. But anyway, we know his Latinized form, that is Nicholas Copernicus. This man, you know very well, he was the person who said, no, it is not the earth which is the center of the universe, he told. Nobody knew what universe was exactly. Actually, sun is the center of the universe. All other planets, including the earth, whatever planets were known, they revolve around the sun. He said, he put forth the heliocentric system. But why I'm showing his picture here means, even on his deathbed, he repented, it seems. I have never seen Mercury. He had never seen Mercury. No. That's why I'm telling Mercury is mysterious. It is very difficult to see. Okay. Before him, there was yet another astronomer. Okay. Not before him, almost a contemporary, let us, Tycho Brahe. You can see. That guy is still fantastic, because without telescope, he noted down the position of the planets. Fantastic. That, anyway, it became useful. Galileo Galilei looked at Mercury, no doubt about it, using his telescope, but it is very, very dangerous to look at Mercury using a telescope, okay, because it is very near to the sun, okay. Twilight means sun would be below. That is different. Precisely this is the reason why Hubble Space Telescope as well as James Webb Space Telescope have not focused their attention towards Mercury. Hubble Space Telescope, at least it can tolerate things. Okay, but anyway, its optics may be damaged if it tries to look at Mercury. Okay. Similarly, James Webb Space Telescope, anyway, it has turned away from the Earth. Okay, that's why it is having a sun shield which is 1 football, not tennis court field, tennis court wide, in fact. 5 of them are there. It can also not turn towards the sun. That's all, it will go away. So these are all the things, technological problems which have made Mercury mysterious. Okay, then Kepler, anyway, he got the data provided, collected painstakingly by Tycho Brahe, who didn't want it to come to him, but anyway, fate had it that it was like that. Then, anyway, Kepler told planets revolve around the sun in elliptical orbits. Mercury, my dear friends, revolves around the sun in an elliptical orbit. When it is very near to the sun, it is only 4.8 crore kilometers from the sun, from the surface of the sun. When it is far away from the sun, it is 7 crore kilometers. That's why I said average is 6 crore kilometers. Okay. Aphelion and perihelion, you know what are all the things. But you know Kepler's second law, actually, planets, the line joining a planet and the sun traces out equal areas in equal intervals of time. It told why. Why? The reason is gravitation. And that is what, I'll come to gravitation also. Okay, that was actually enunciated by Newton. And anyway, after Newton's time, Newton, he perfected what is known as a reflecting telescope using a mirror. All of us, we have so many reflecting telescopes, but our observatory is having a 6 inches refractor using a lens. So anyway, telescopes became more and more bigger, and they became more powerful, but despite that, the problem is you cannot look at Mercury easily. So, but is it over then? There is no other way to observe Mercury. At least you can observe Mercury when it passes in front of the sun's disk. Of course, you have to use a filter and all those things. Otherwise, the eyes will be burnt, first of all. So this is called as transit of Mercury. Okay, it is some kind of an eclipse, but it is a misnomer if I call it as an eclipse, because sun's disk is too large compared to a tiny marble like Mercury. The coincidence, like, sun is 400 times away from moon, but it is 400 times larger, but moon is 400 times nearer to us compared to sun, but it is 400 times smaller, means both of them, they look half a degree from our perspective. That is not the case. You can see solar disk is so large, and this one you can observe Mercury and try to find out certain things. Okay, that's what they did. And Of course, much later, in the 1930s, after Karl Jansky, he perfected radio astronomy using radio telescopes. You use many radio telescopes like this. They can be satellite antennas also. This is a Goldstone antenna in Goldstone, California. Okay, like this in many radio telescopes are there. You can use them to, okay, study Mercury even. They have done that. In fact, many people were thinking that Mercury was tidally locked to the sun. Moon is tidally locked to Earth in the sense, Moon takes 27.3 days to go around the Earth once. But it takes 27.3 days only to spin around its own axis once. So the end result is we can only see one portion of the moon or one hemisphere of the moon. The other hemisphere is not visible to us. Call it as far side of the moon, okay? Don't call it as dark side of the moon, because it is equally illuminated. When it is Amavasya here, that is Paurnima there on the other side. So vice versa is true. So, but anyway, using radio telescopes, scientists found out that Mercury was not tidally locked. That is, it was going around the sun once in 88 Earth days. That is known. Kepler's third law you can use and find out. But it was not spinning around its own axis also once in 88 days. No, it was spinning once in 59 days. Roughly they came to the conclusion using radio telescopes, in fact, okay? Radar, to be more precise. Radio telescopes somehow act like radars, in fact, okay? So, transmit and receive. But humans, you know, I show this slide always. Humans, by birth, by nature, they are exploratory in nature, in fact. It is in their psyche. So, you know, the thing is, Captain Mallory, there was a mountaineer, British mountaineer. He led many Everest expeditions. Somebody asked him, it seems, why do you want to climb Everest? He told it, because it is there. So that is in the human psyche. Okay? Captain Mallory got killed while climbing Everest once. But humans are like that. So many people have died while traveling to space. Have humans stopped going to space? No, that's the way. So, anyway, humans were craving for traveling towards the worlds that were visible in the night sky. And anyway, they could able to perfect the technologies to travel to space. On October 4th, 1957, Sputnik 1, world's first artificial satellite, was launched. Okay? After that, this heralded the dawn of the space age. Okay? After that, so many robotic probes were sent towards the other planets of the solar system. The first one to be explored as early as 1962 was Venus, the nearest planet to us. Okay? Even when, let us say, when Venus is very near to us, it is at a distance of only, on the average, 4 crore kilometers. That is almost about 100 times as much as the distance between Earth and Moon. Okay? That is the thing. In 1962 itself, a spacecraft was launched towards Venus, and it explored the planet quite well from that day's technology point of view. Then Mars, as early as 1965, Mariner 4 went. See, let me tell you, thanks to space technology, this is one of the greatest benefits from space. Otherwise, whatever circus you do from the surface of the Earth, the heavenly bodies, especially except for the Moon, our next door celestial neighbor, apart from that, all others are crores of kilometers away, hundreds of crores of kilometers away. How do you discern anything about them? Unless you go there, you will not be. Which has enabled you? Space technology. Today, if I have learned a lot about the solar system, and progress has been tremendous, revolutionary, thanks to space technology. That is why I have put it under benefits from space lecture series. So like this, I'll be talking about each and every planet of the solar system. Already I have talked about Mars. Moon. Moon qualifies as a planetary body, though it is a satellite in terms of size. Venus, Moon, Mars. I have done already today. Mercury, like that. Jupiter, Saturn, Uranus, Neptune, and Pluto is a fantastic world. I'll talk about it a little later. So after this one, Venus, it was Mars, which was explored as early as 1965. Then even humans launched a spacecraft towards Jupiter in 1972. What about Mercury? It's not easy. Not only from the observational point of view, there are other difficulties. But as early as, as late as 1973. Sputnik 1 was launched on October 4th, 1957. This was 1973, end November or something like that. A spacecraft was launched towards Mercury. That was known as Mariner 10. Okay, this was the spacecraft. So this is the spacecraft. You can see the cameras, you can see the antenna, you can see the magnetometers here. So these are the things. Who is this gentleman? His name is Bepi Colombo. Okay, his name is Giuseppe Colombo. Giuseppe is nothing but Joseph in Italian. Okay, Joseph Colombo, Columbus or whatever it is, that name. So this gentleman actually calculated something which is from celestial mechanics point of view. He said, if you want to launch something towards Mercury, either into an orbit or towards this planet itself, then you can take advantage of the gravitational fields of other planets, especially nearby planets like Venus and Earth, and even Mercury itself to a certain extent. So that is why a spacecraft which European Space Agency has already launched in 2018 is having his name, Bepi Colombo. Okay. Now anyway, this gentleman, whatever he had calculated, using his calculations or taking it as a cue, Mariner 10 was launched by NASA in 1973. So what did it do? It did not go towards Mercury directly. See, one thing we have to understand, Earth is revolving around the sun, okay, at a tremendous speed we can't even imagine, at 30 kilometers per second. That is the speed with which it is moving, sideways, so-called tangential velocity, 30 kilometers per second. What about Mercury? As per Kepler's laws, when planet is nearer to sun, so it has to move very fast. It is moving at 48 kilometers per hour. So, if you want to fall towards the sun, okay, after all, Mercury is very near to the sun. From Earth orbit, you have to fall towards the sun. Towards Mercury means you have to cancel out your orbital speed. So, Earth is moving like this, from the North Pole if you were to see. So, all the planets are revolving around the sun in anti-clockwise direction. Okay? Earth is moving like this means you have to cancel that speed. Then only you will come down. You will go down towards Mercury. Even Shubhanshu Shukla, once he will be in space, when he wants to come back, he has to reduce the speed. Mars Orbiter Mission spacecraft, that's what we did. We decelerated it to enable it to go around Mars. Similarly, if you want to fall towards the sun, you have to cancel the speed with which Earth is moving. It's not easy. Okay. So in terms of rocket power, it is highly demanding and wasteful. It's not easy. And you cannot provide the impulse in 1 second. Okay. All the impulse in a second. No, it is not possible. So anyway, take advantage of the gravitational field of Venus. That is what Mariner 10 did, and it went near Venus, took advantage of its gravitational field. It was carefully targeted in such a way, it got decelerated and fell towards the sun, towards Mercury. So what instruments do these kind of spacecraft have? Do they have only telescopes? Okay, they will have different kind of spectrometers will be there to know the elemental composition or in general chemical composition. Okay, this one, mineralogical composition. For that, different kinds of Infrared spectrometer will be there, ultraviolet spectrometer will be there, gamma ray spectrometer will be there, X-ray spectrometer will be there, neutron spectrometer will be there. So all these things will be there, and cameras will be there, and an antenna which can act as a radar also, which will be there. Magnetometers will be there. Okay. So this is using all these things. They take a holistic reading of what is happening on and in the vicinity of Mercury, let us say. So, and these kind of spacecraft, they don't take loudspeakers and speak. Whatever scientific data as well as their health and such things they get, they whisper only. They whisper. Transmitter power will be impossible to, this one maybe 20 watts, 40 watts, 50 watts, that's all. So by the time it reaches the earth, you will not know what is signal and what is the cacophony of noise. That is why these kind of antennas, this antenna is very near to this one, Bangalore, called Pyalalu. Okay. So this is the thing. Now I am coming back to Mercury. Mercury's orbit, I told you, it is highly elliptical, and it is moving very fast when it is near perihelion, and it is moving slowly at aphelion, and it is not easy to approach this. At the same time, it will be much more difficult to enter into an orbit around it. Okay. Now this was the first picture of Mercury. People came to know as to how Mercury looked for the first time in 1974, early 1974. Nobody knew how Mercury looked, either through the naked eye or from any orbiting telescope or from any ground-based telescope, or nowhere. But look at that. This is the way. When you look at it, what you remember? Obviously moon. So, are they similar? Or are they same? Maybe similar somewhat. Look at that. You have innumerable craters. But these are known as Maria. These eye kind of thing, here and this. This is Sea of Tranquility, and this is where Neil Armstrong, actually this laser cannot be seen. And this is where Neil Armstrong landed, Sea of Tranquility. Okay. So, these dark areas are lava plains. They are known as mare. Mare means sea in Latin, and even in today's Italian also. Mare tranquillitatis means sea of tranquility. Mare crisium means sea of crisis. Mare orientalis. So like that, fanciful names are there. There is no sea there, but historical reasons. But you don't see such mare or Maria there on Mercury. No, lava plains like that are not there, like the moon. But you have what are known as, can you see here? Like a crack kind of thing. Can you see there? Okay, they are known as lobate scarps. Lobate scarps means, like, for example, Yana you have seen, in Karnataka, some escarpment kind of thing. That's too small. But if you go near Western Ghats, okay, or if you go to northern Canada and all those things, you will see a scarp. Okay, if you just go and fall, you will fall into some kind of a precipice. So that kind of 1 kilometer, 2 kilometer high escarpments, okay, they are known as lobate scarps. Okay, they are there on Mercury. Why? Why is it? The reason is the planet has shrunk. Because of that, these kind of things are visible. Mind it, these kind of things are visible only to a spacecraft, nowhere else from Earth. Forget it. So look at that. So this picture was when it was approaching Mercury, Mariner 10, and this picture it took when it was receding from the planet. 3 times it passed very near to the Mercury, but the problem was all the 3 times the same hemisphere was illuminated. So only it could able to picture take image only 45% of the surface of Mercury. And this is the south polar region of Mercury. Okay, this was also taken by Mariner 10, and there is a huge crater, okay, a basin Basin is much bigger than a crater. This is known as Caloris Basin. This is 1,500 kilometers in diameter. Probably in the early history of Mercury, an object which is as big as 100 kilometers in diameter might have come and hit it. And the hit was so powerful, if you go to the other side of the planet, it is called as antipodal region. You will see certain features. The shock waves which travel through the center of Mercury, they have created those features also. That big hit it was. But only again, partially this Caloris Basin could be photographed by Mariner 10. Surprisingly, Mariner 10 detected a magnetic field for Mercury. It was least expected. Okay, it detected a magnetic field somewhat similar to Earth, but only 1% of the Earth's strength. So that is, and another thing which it detected was, magnetic field when it detected means it should have iron core. That is what they think, at least as per the Earth's model. So that was indirectly found out. And another thing is Mercury is having an atmosphere. That was another unexpected thing. Mercury is a small planet and very near to the sun. Whatever atmospheric particles that are there, they achieve escape velocity because of the sunlight comes and impinges on them. And Mercury is too small with a small gravitational field, it cannot hold. So that's why they have escaped. But they found still what is known as an exosphere around Mercury. See, all these things not possible without spacecraft. So look at the magnetic field of Mercury, similar to Earth. At that time, they thought it was similar to Earth, and only 1% of the strength of the Earth's magnetic field. And again, I'll come to Venus. Why? I'm moving back and forth because the reason is this. Mercury is so small, having a magnetic field. Venus, 12,100 kilometers diameter compared to 12,756 for the Earth. As big as the Earth almost. Why it doesn't have a magnetic field? It doesn't have a magnetic field. Venus. What is so special about Mercury? Why this step-wonderly treatment by God? Okay. Then what about Mars? Mars is having a diameter of 6,900 kilometers compared to 4,800 kilometers for Mercury. Why it doesn't have a magnetic field? No. Venus and Mars doesn't have. What is so special about Mercury? Why? This is a question still haunting to a certain extent. And let me come to the temperature. Okay, if you stand on the surface of Mercury, let us say, okay, you travel in a special spacecraft. Happily, you can stand on the surface of Mercury. Good. On Jupiter, Saturn, Uranus, and Neptune, you can't even stand. There is no solid surface. No solid surface. So, you can stand on Mercury at least. Okay, but if you are standing there, sun is there, you are on the sunlit side like this. We are on the sunlit side of the Earth. Your temperature will be only plus 425 degrees centigrade. Plus 425 degrees centigrade. You don't like it, you walk towards the night side. Go there to the other side. My goodness. Is it 20 degrees? 10 degrees? Or at least minus 5 degrees? No. On the night side, it is minus 173 degrees centigrade. Or roughly 180, minus 180. Plus 425 to minus 180. Look at this. Wild variation in the temperature on the surface of Mercury. That is the way it is. No atmosphere for all practical, from breathing point of view. Sun will look 3 times as big as it is from in the Earth sky, 11 to 12 times brighter, because very near. So, anybody wants to go to Mercury? Well and good. Okay? And no protection from harmful radiation, harmful subatomic particles, nothing. Okay? Then, for 3 decades, you see, 1974 and 75 was the time during which Mariner 10 was there. Then came, in 2004, NASA launched a spacecraft called Messenger. It is an acronym. Okay? Mercury surface, geochemistry, space environment and ranging, that kind of thing. Okay? That is messenger. It comes like that. They are known for this kind of histrionics, in fact. Very good, but they have explored extremely well. Okay, now you can see a sun shield is there for this, and it went towards Mercury. It took 6.5 years to reach Mercury. Again, not because of rocket power. It is because it took gravitational slingshot from Earth, Venus, and Mercury itself. What did it do? Let us see what it did. Okay? See, sun's gravitational well is so deep. When you are in the outer solar system, okay. As you go nearer to the sun, look at the steepness with which this gravity well is there. So Mercury is in the deeper part of the gravitational well. That is why I said it is not easy to cancel out your orbital well. The so-called sideways velocity. Sideways is for a common man, not for people like you who are studying in science. Tangential velocity, let us say, that kind of thing. Okay, you have to cancel. It is not easy. That's why you are taking advantage of that. One thing is, it is a treacherous ambience when you are very near to Mercury. That is why you have to have a sun shield when you are orbiting Mercury. So this sunshade is made up of a ceramic cloth. Okay, of course, different instruments it had. Okay, solar panels it had, and let us see what it did. Of course, Mariner 10, only 45% of the surface of Mercury it had photographed. This spacecraft, before it went into an orbit around Mercury in 2011, 99% of the surface of Mercury it imaged already. Okay, then it went into an orbit. I told you, first of all, it is difficult to approach Mercury. It is much more difficult to put it into an orbit around Mercury. That is what they did, into an elliptical orbit. And that is how you could able to see. By 2012, the mission was over. They extended to 2013, 14, and as all good things come to an end, in 2015, its orbit was lowered, and it could no longer be controlled. It was made to crash into the surface of Mercury. It created a crater which is 50 feet wide. Okay. Now no longer, but it has done a lot. Look at that. This is the picture of Mercury. Okay, taken by messenger, and you can see some of the things, craters and the mountains within the craters. Ejecta, when it goes and falls again, you know, this is the kind of thing. And so mineralogy also, they could able to study. Okay, mineralogy in the sense what elemental composition, not very detailed one. Okay, by and large it is okay. So look at that. This is the Caloris basin. Okay, I told you only partially it was imaged by Mariner 10. This was full, and you can see, you can study the geology and geological history of Mercury through this. See, first there were very big hits by larger bodies, planetesimals kind of thing, and that is how lava plains are there. On top of that, much later, you have much smaller impacts that you can see there. Okay, and these are all these ray kind of things are there. Means even on the moon, if you see a material of different color, they are relatively new, relatively, not yesterday or anything. And you know, to its greatness, the spacecraft messenger, it discovered water, ice, and sulfur in the polar regions of Mercury. How is it possible? Mercury is so near, but the axis of Mercury is actually tilted at 90 degrees from its orbital plane. How much hours from the vertical? It is tilted by 23 point. Today is 21st or 22nd? 21st. Tomorrow, June 22nd, maximum daylight. Look at that, because of the axial tilt. That is not the case in Mercury. So there are areas in the polar regions which are under permanent shadow in the craters, where eons ago comets might have hit, asteroids might have hit, and they might have brought water. and it is still there. Water ice. That's what they think. So look at that. This is yet another North Polar region of this one. Mercury is photographed, imaged by a messenger spacecraft. And look at that. This is the way pictures are taken, You should know the orbit properly. And when you switch on the camera, where it was, all those things. Of course, all these things are very well established nowadays. We used to do in ISRO the same thing on Earth using our Indian remote sensing satellites. So, I told you already, this Mariner 10 discovered a magnetic field which is 1% strength, okay, which has 1% strength. But this characterized it much more, in a much more detailed way. And that is what it did, Messenger. And Messenger found out one more thing, that is, Mariner 10 already had found out that there is an iron core for Mercury. Messenger said, I mean, these are all indirect derivations, okay? The core is molten. That is what it said. That is very important, okay? Partially. So look at, and magnetosphere of Mercury, how it is. You can have a look at it, okay? Solar wind comes and it impinges. Mercury is having a magnetic field, but it doesn't have what are known as Van Allen radiation belts kind of thing. Anyway, I'll come to that. Now, Messenger did so much, okay, in terms of magnetic field, in terms of atmosphere, Mercury's atmosphere, it found out helium, okay, sodium, calcium, oxygen, all these things were found using Messenger data. See, it is an incremental step. Now, the next incremental step is Bepi-Colombo. Bepi-Colombo was launched in 2018, and it is traveling towards Mercury, and it will be orbiting Mercury in late 2026, late next year. It would have done this year itself, thanks to its ion engine, that is electric thrusters. It is not using chemical rocket engine, electric thrusters it is using. Their performance was not as expected, so that has delayed. So this is a technological problem, nothing to do with celestial mechanics. Okay, now actually this Bepi-Colombo spacecraft, which is European Space Agency's, it is having two parts. One is Mercury Planetary Orbiter, Mercury Magnetospheric Orbiter. Two are there in fact, okay? So this is the way, and lots of challenges are there, technologically speaking, in terms of temperature, in terms of solar panels, in terms of orientation control and such things. Anyway, I don't want to go into details. You can see the ion engine, okay? Electric propulsion is very advantageous, okay, from many points of view. And now you can see how this Mercury Planet Orbiter and Mercury Magnetospheric Orbiter, how they orbit Mercury. Once they go into orbit, you can see. You can look at Mercury Planet Orbiter of ESA, okay? Look at that. The ellipticity is not too much. It is traveling relatively near to Mercury in its orbit. But look at the magnetospheric orbiter. This is provided by Japanese Aerospace Research Agency, Exploration Agency, JAXA. Okay, that is having a highly elliptical orbit. So to get complementary data and to make it work for a longer time. Okay, this is the thing. And the way in which Bepi-Colombo went towards Mercury, you can see this, hopefully, yeah. See how it started from the Earth, how many times it took gravitational assist, okay, gravitational slingshot from Earth. It has left Earth orbit. Look at that. See, Mercury is there, Venus is there. It has, you see, it comes very near to Earth again, having been launched from the Earth. Again, it comes near the Earth and gets gravitational boost. Yeah, look at that. Yeah, one gravitational boost. Okay, then see how its path got altered. Path is trajectory. Okay, look at that. Then it is coming near Venus, and anyway, Venus also comes there. Yes, another slingshot. Yes. Look at that. How you direct the spacecraft towards a planetary body and how it changes its velocity. That is both in terms of magnitude as well as in terms of direction. That is what you can see. See, it has taken, yeah, it's going around Mercury also. When it meets Mercury, yes, another gravitational slingshot. See, it is nearing Mercury. So ultimately, that is how it went into an orbit around Mercury. Finally, you can see. You can wait for another half a minute. How it entered into an orbit around Mercury. See, another gravitational slingshot. And finally, you will see it going into an orbit around Mercury itself. Okay. Okay, that's the way. Then, this is the way the spacecraft looks. This is an artist concept by putting the planet as well as the spacecraft. And this is a real picture of taken by Bepi Colombo's camera. You can see the magnetometer. You can see one of the instruments here. Okay, probably I'm not sure about it, what it is. Maybe an antenna, somewhat. It looks like that. I'm not sure. This is a magnetometer boom, I'm sure about it. And this is planet Mercury. This is the real picture on its way to Mercury. It has not yet started orbiting Mercury. Now, sir, all these things are known about Mercury. How can you call it as mystery? How can you call Mercury as still mysterious? There are many things astronomers want to know about. See, this has been summarized by many people, even in many encyclopedias, all these things. One thing is, we want to learn about the formation of the solar system. You know about nebular hypothesis and all those things. But what were the conditions? What was the status of the solar nebula when Mercury was formed? Why it is the way it is? So you have to understand. Of course, Bepi Colombo's data are the other spacecraft which are going to be launched, that data may provide. Second thing is, what is why astronomers are scratching their heads is, Mercury is such a small planet. Why its density is so high? Okay, a little lower than Earth's. But why? For such a small planet, why? And it is having a molten core. Really, is it having a molten core? If the planet were to be hot, then it would have cooled rapidly, unlike Earth. But why? It is having a molten core, at least the outer part. This is what not yet known. Probably some data. And what about this one? Is it shrinking still? Mercury? Okay, lobate scarps I showed you. Whether is it shrinking even today? They have to collect lots and lots of data. Okay, that is another mystery associated with Mercury. And one of the events. Oh, oops. Okay, I don't know. Okay, don't worry about it. Can you do that? See, there is an event, some hit by some meteorite or something is there, and how it shows up. Unfortunately, oh, it's there. Can you see that? When something is hit, can you do it once more? Please be careful. See, something is hitting the surface of Mercury. You can see the plume also. Anyway, don't worry about it. You saw once. Okay? So, Mercury, in response to that, how dynamic it is. What is its present status? Whether its crust is dynamic. Once upon a time it was dynamic. Whether it is so even today, they want to know about it. And, the mineralogical composition of Mercury. See, Mercury is mostly metals, and silicates. But there is no signature of iron easily, but it has got a magnetic field. How? This is another puzzling thing. So, similarly, Mercury has a magnetic field. Why? Why it should have a magnetic field? First of all, it is a small planet, moving. Earth is 12,756 kilometers in diameter, a big planet and a big core. Outer core is in the liquid form, and the motions in the liquid outer core, okay, the currents, they generate the magnetic field. That is the dynamo effect. Okay, but Mercury is small, 4,800 kilometers in diameter, and 70% of that is core. Okay, even then. But what about its speed of spin rate? 59 Earth days. Ours is 24 hours. That is why we are generating magnetic field. How it can generate? Probably. This one of you may do some research on that. And how is the exosphere of Mercury? What does it contain? How did it evolve? Why it is in its present state? So this is yet another question. And you know, when we think of Earth's magnetic field, okay, we see aurora, okay, aurora borealis, aurora australis. Fortunately, I could able to see aurora borealis once upon a time, 1997. Oh, what an experience it is. Okay, so because of Earth's magnetic field, we see aurora. We have geomagnetic storms, which can affect satellites, which can affect high frequency radio communication, which can affect our GPS spacecraft, which can affect our astronauts, which can affect our power grids. Is it the same in the case of Mercury? No, nobody is there. But what kind of interaction between this sun's output as well as the magnetic field of Mercury? How do they interact? They want to understand more. Van Allen radiation belts are there on Earth. Is there? They have not been found on Mercury. And finally, why did I come to Albert Einstein? The reason is there. See, when Mercury's orbit was carefully monitored, they came to know the perihelion of Mercury, okay, the nearest point to the sun, it was precessing, okay, it was rotating within the orbital plane itself, like this. Why? Anyway, Newtonian physics, actually it could able to account for most of the things. Let us say from the gravitational effects of the other planets. It is not a strictly two-body problem. Other planets are also, they may not be as powerful as the sun in terms of the gravitational field, but they have their power. But there was some small discrepancy which could not be accounted for. That resulted in an hypothesis which said there is a planet between Sun and Mercury called Vulcan. Anyway, nobody could able to find. And finally, Albert Einstein in 1915, when he proposed general theory of relativity, he could able to account for that. Exactly, almost it matched, almost. Now, a spacecraft is there very near to Mercury, and the way in which gravitational field of Mercury and the gravitational field of the sun on Mercury, the way in which it affects, you can study it with the help of a Bepi-Colombo spacecraft or even maybe future spacecraft. Can you refine that? It's always there. This is what they want to do using Bepi-Colombo and the future spacecraft. So, I'm sure that with this, you agree with me that Mercury is a mystery even today. Okay, a lot of things have been known about Mercury, but still, lot of things are yet to be known, and lot of things are to be known precisely. That is the beauty of science. Okay, velocity of light, when it was measured by Wallace Romer in 16th or 17th century, and ultimately what Albert Abraham Michelson, he measured. Okay, there is a difference, velocity of light. So you improvise. There is scope for improvement always in science. And in that process, you will learn a lot. This is the way even Einstein thought, if I imagine like this, what happens? That's the way. Newtonian physics was not able to explain everything under special circumstances. Let us say when you are moving at the velocity of light, what happens? It is different. Okay? So, scope for improvement, scope for gaining additional knowledge is there. So, Mercury, still it is a mysterious planet from many points of view, but at the same time we have learned a lot. And scope for learning more is always there. That is where students like you and even general public, okay, they can appreciate at least. That is what is definitely is going to happen. Okay, that scope is there and people take advantage of that and things will be improvised and science will progress. I'm an optimist in this, and I'm coming back to the solar system, my first slide again. Why? So we know a lot about solar system, the planets of the solar system. Okay, maybe Uranus, Neptune and Pluto, only one missions we have sent, but still when those spacecraft went, we learned a lot. Okay, but in the case of Mercury, which is very near to us, we have to learn quite a bit, and learning about Mercury has got many advantages for us. So hopefully in future these mysteries will be demystified. The planet itself will be demystified thanks to science, thanks to space flight, and this is one of the benefits to accrue to humanity from space flight. That is why under benefits from space lecture, I told you about the way in which robotic spacecraft have revolutionized our knowledge of planet Mercury. Thank you very much. And if you have any questions at my level, yes, I'll be very happy. At least, if not possible, let me also read, let me accept. Any question is there, please, if you have. No. Thank you.
One person online asked, is Mercury shrinking?
Yes, it has shrunk already. That is what they want to know. It is shrinking still. Okay? Some people say, yes, it is shrinking. But to what extent? I don't know about it. But it has shrunk earlier. That is the reason why lobate scarps are there, in fact. Okay? But it was hot and it cooled and surface cracked, no doubt about it. But it's a long time since those things have happened. I'm not sure. That is what that data has to come from the spacecraft. Okay, thank you. Any other thing? Okay.
Thank you
There
all.
are no questions.
Yeah.
Thank you. Thank you very much. Once again, I request you, in Planetarium, we have plenty of things. 30th of this month is World Asteroid Day. 30th being a Monday, which is holiday for us. 29th, we have a lecture. I'm speaking again on survival at stake. Okay? How we can protect the Earth from an asteroidal attack. This is not a doomsday lecture or anything. Just I want to tell you actually what are all the possibilities. Many people say that the asteroid is coming means it will hit at any cost. That is not the thing. What is the probability? Always this. And that changes. Apophis, you see, things have changed. Anyway, kindly do come. Many lectures are there. We are so many lectures we are arranging. Okay, kindly do attend and tell your friends. Okay, thank you. Thank you very much. Thanks to all my colleagues who have helped in today's lecture, arranging this. Thank you. I thank one and all. Thank you. Good day.
Thank you. Please have the refreshments which is served outside.